Let's take a look at what we actually learned in the previous topic when we rounded out all of our known derivatives and differentiation rules, and that's how we take the derivatives of inverse trig functions. So once again, we're going to let u be a function of x. It's one thing to understand the derivative of inverse sine, but we want to take the inverse sine of something, perhaps, and take its derivative. So letting u be a function of x allows us to express this. Well, we have that the derivative with respect to x of inverse sine of u is equal to u prime. Again, that's from the chain rule over the square root of 1 minus u squared. If I take a look at the derivative with respect to x of inverse cosine of u, that is equal to negative u prime over the square root of 1 minus u squared. And then if I take the derivative with respect to x of inverse tangent of u, that is equal to u prime over 1 plus u squared. All right, let's take a look at the other ones that we have here. We have the derivative with respect to x of inverse cosecant of u, and that is equal to negative u prime over the absolute value of u times the square root of u squared minus 1. And again, when we do these, make sure we look at what the argument is inside of the inverse trig function, because not only do we need it for the chain rule here in u prime, but a lot of times in the denominator, we're plugging in u and sometimes squaring u. So make sure we understand that u is just whatever the argument is inside this inverse trig function. The derivative of inverse secant looks a lot like inverse cosecant, but without the negative. It's u prime over the absolute value of u times u squared minus 1. And then last but not least, the derivative of inverse cotangent of u is equal to negative u prime over 1 plus u squared. So there they all are. Really, if you take a look at these first 3 videos of this lesson, there's our derivatives. Make sure we apply the chain rule, which is what this u prime is indicating very frequently. But that's it. Now you have a really handy reference sheet with all of your derivatives and all of your rules for differentiation. And now we can kind of go forward and start taking the derivative of any function and then looking at some of the applications of them.